Welcome to Section 1.2. This is about solving multi-step equations, and we're going to actually start just in this part with two-step equations, and then in part 2 I'll take you through what to do when you've got terms that you can combine or things that need to be distributed, all of which are going to then come down to a two-step equation. To solve a two-step equation, you're basically going to be using things that you've learned the last few years, including the processes for solving one-step equations, also all the different operations, adding, subtracting, multiplying, and dividing with decimals, with fractions, with mixed numbers, and with negative numbers. Remember that with inverse operations, you're talking about operations that undo each other. So addition undoes subtraction. If you've added 5 and then you subtract 5, you're back where you started. Same thing works with multiplying and dividing, where if you've divided something by 5, but then you multiply that answer by 5, you're also back where you started. So those are called inverse operations. They undo each other. Remember that when you're solving equations, and you went over this with one-step equations, whatever you do to one side, you have to do to the other side. That's what's going to keep them equal. If two things are starting out the same and you change them in the same way, then they're still going to be the same. Remember also that after you've solved an equation, there's a real easy double check. If you just take the answer that you got at the end of it, and then you take it back to the beginning of the original equation. You replace the variable with that solution, and then your equation should be a true numerical statement. You should actually, after you do the math, or the arithmetic at this point, you'd end up with something like 10 equals 10. If you don't end up with a true numerical statement, it means that your solution is wrong, or that you made a careless mistake in plugging it in. In either case, you want to definitely double check something, because if it's correct, you should end up with a perfectly true numerical statement. When you approach a two-step equation, you actually will have at least two operations. That's why it's called a two-step equation. Usually in them, there will be some addition or subtraction, and there'll be some multiplication or division. It's going to be easier if, first of all, you undo the addition or subtraction, and then after you've done that, you then undo the multiplication or division. As we go through the first one, I'll actually work it out both ways so you can see that you can get the correct answer either way, but that it's going to be a much easier process for you if you undo the addition or subtraction first. So in this two-step equation, you'll see that you have your variable x, and there are two numbers that are on the same side as the x. There's a 2 and there's a 9. And in order to solve this equation, we need to get the x completely by itself, and that's called isolating the variable. So how's the 2 connected to the x? It's connected by multiplication. How's that 9 connected? It's connected by subtraction. So we're going to undo that subtraction first. So we're going to add 9 to the left side, and then whatever you do to one side, you have to do to the other to keep it equal. And so that's why, actually, as you're writing it, you want to put an equal sign, and this second line should actually be sort of a statement of the obvious, that adding 9 is the same as adding 9. After that, we're then going to take a look at what we have. So now that minus 9 is gone, and all that's left is the 2x. You could write a plus 0 if you want, but it's not really going to change anything. On the right side, you're going to need to use your rules with negative numbers. So you're starting out at negative 4, and then you're adding 9. So if you owe $4 and you add $9, you can pay off your debt, and you have $5 left over. And so that answer is a positive 5 there. Now that we've done that, that's step 1. Step 2 is going to be undoing the multiplication. So we undo that by dividing. So we're going to divide the entire side by 2. You have to do the entire side, and whatever you do to one side, you do the other. And so once we've done that, these will cancel out, and then you're left with only the x on the left side, which is perfect. That's exactly what you want. And then on the right side, this isn't going to go in evenly. Okay, so you have a choice. You can either write it as a mixed number or as a decimal. In this case, it's not going to matter because the problem didn't start out with fractions or decimals. So therefore, you have a choice. So I'm going to write it. It's a pretty easy number either way. I'm going to write it this time just as a fraction. a mixed number, but you could certainly do it as a decimal. Now that we've done that, let's do a double check and make sure that it works. So I'm going to rewrite this now as 2 times that 2.5 minus 9 equals negative 4. So as I work that out, this part, 2 times 2 is 4, 2 times a half is 1, 4 plus 1 is 5. So that's now 5 minus 9 equals negative 4. And we say, oh, well, 5 minus 9 really is negative 4, so therefore that's a true statement. One thing you'll see often in a double check is actually the equal sign will have a little question mark above it, because what you're doing is you're saying, well, is 2 times 2.5 minus 9 equal to negative 4? So we're questioning it, we're testing it. So I'm going to put a minus there, and then at the end, negative 4 is negative 4, no question mark needed. We know that that's true. So now, here's one for you to try. So pause the video, work out the problem, see what you get, and then when you're finished, resume the video. So this time, we have two numbers connected with the variable again. We have a 4, which is connected by multiplying, and we have a 9, which is connected by adding. Which one are we supposed to undo first? The adding. So how do we undo adding? By subtracting. And whatever you do to one side, you do to the other side. Now that we've done that, that 9 is gone. All that's remaining on the left side is a 4x. 10 minus 9 only gives you 1. Next step, we have to undo the multiplication, and we undo that by division. So now we're going to divide both sides by 4, and then we're going to the 4's will cancel out on the left side, which is what we wanted to happen, and 1 divided by 4, well, that's just 1/4. So we've got that there, and then now what we're going to do is plug it back in and make sure it works. So we've got this 4 times, now instead of the x, there's a 1/4. We're still adding 9, and we get 10. The 4 times the 1/4 gives you 1, because 4/4 is 1, plus 9 equals 10. And again, I'm going to put a question mark there because we're testing this theory, and therefore 1 plus 9, as you learned back in first grade, really does equal 10. And so, yay, got it right. So I want to show you the problem again done in reverse order, where we're going to undo the multiplying and then the adding. And what I'd like you to see is that we are going to get the same answer, but it does get a little bit tricky. The numbers are going to get a little messier. So that's why I really recommend that you undo the adding, subtracting first, and then the multiplying and dividing. So let's look at that 4. It's attached by multiplying, so we're going to divide. And we need to divide the entire side by 4, because it's whatever you do to one side completely, you do to the other. So it's not just dividing the 4x, you have to divide the entire thing. So when I do that, I get the 4x divided by the x, 4x divided by 4 is just x, which, hey, that's nice and easy. But now look at the next part. You have 9 divided by 4. For now, I'm just going to leave that as an improper fraction, but you could change it to 2 1/4. You could change it to 2.25. I'm just going to leave it that way because I'm looking at what's on the other side. And then on the other side, I've got this 10 over 4, which I don't really like either. I've got these mixed numbers, these improper fractions. The numbers aren't quite as clean, but it's still going to work out. I now have to undo the addition, which I undo by subtraction. So I'm subtracting this 9/4, which I don't really like, but that's what I have to deal with. And then once I'm done, I have the x equals the 1/4, which of course is the same as what you got last time. Why is that? Because it's the right answer. But so it does work either way. Again, what I've seen is a lot of students tend to forget that they have to divide the entire side by that coefficient, the 4. They're in a rush. They just divide the 4x and they forget about the 9. So it tends to be easier, safer if you just undo the adding and subtracting first. It's the same amount of work either way. Either way, you have two steps. You have to undo the adding or subtracting somewhere, and then you also have to undo the multiplying or dividing somewhere. So you're not really saving any time. Again, I just think it's easier to do it that way.